Welcome to a series of introductory videos for InventorCAM. This video's topic is pocketing. So the pocket toolpath in InventorCAM works similar to other toolpaths in InventorCAM, where we're just going to choose some geometry, choose our levels, choose our tool, and then just tell it how deep into the part we want to go. Specifically, pocketing is for a cavity or a island feature, prismatic feature of your part. And you can see here that I have a couple of steps on my part. So let's see how the pocketing toolpath can be used on this part. So I'll just right click, go to milling operation, pocket. And the first thing you'll see is that we are choosing our geometry, but we have a couple of other features here that I'll go through. But first, let's actually just choose the geometry. So I'm going to start by doing the larger pocket of this feature here. And I'm just going to go over to the left side here and we'll talk about these real quick. So we're going to choose chain geometry, meaning that we're going to choose either a sketch or an edge off of the solid. In this case, we'll choose the edge off the solid. We'll just choose this edge right here. Before I click on that, I'm just going to turn these guys off, so that when I click on that one entity, either a sketch or an edge, it's just the one. It's not going to go through and choose everything for me. If I were to choose constant Z, it would find a constant Z relationship with the rest of the edges. In this case, this being a flat surface, it'll just go through and grab all those edges for me, defining the outside edge of the pocket. The same would go for tangent propagation. When I click on tangent propagation, it does the same thing. Instead of looking for a flat planar relationship, it's actually looking for any relationship between tangential edges. So all of this being tangent would also be selected. But tangent propagation can also work anywhere in the 3D as well. So if this was a circular part, or if this was a part that had a lot of tapers on it, but all those edges were fillets and all those edges were tangential to each other, then it would automatically choose all the edges for me. Next to the chain list, you'll see some other options there. Those, again, are just a way to make it easier to select the chain geometry. I could go around and individually choose all the other edges just to continue choosing edges. But what I want to do is just go through and do the easy buttons over here. So I can say, just click the next element. So as long as it's in that same direction, it'll just choose the next element for me. And you can see the white arrow is pointing in the direction of the next element. But that vertex actually has two directions it can go. It can go in this white line or this white line. To change direction without even going to the part, I just have to click this option here. So that just changes direction. And all that means is it's going to go down that line and then continue in whatever direction I want it to go. So if I want to keep going in that direction, I can keep clicking next. If I want to go down that direction, next, and I can go around and choose all the pockets. Now, again, I don't want to have to go to the part just to unselect a feature. Let's say I didn't want to go that, I wanted to continue going along the top. I can go undo. So it's just undoing the last couple of clicks, just in order, like that. If I'm choosing my chain in the wrong direction, right now I'm doing climb milling, but for whatever reason, let's say I need to switch it to conventional. I need the chain to go in a different direction. I can just click on this reverse button, and it reverses the direction of the pocket. And now that it's reversed, if I click next, you'll see that it's going in the other direction. It's just auto-selecting the next entity wherever the white arrow is pointing. But of course, again, I want climb milling, so I'm just going to switch it to that, and we'll just continue all the way through. I can just keep clicking on next as we go along. And you'll notice that there's actually two colors popping up there. If we zoom in on the part, let's zoom in on this edge over here. As it's being built, it's actually showing the selection and the projection to the working plane. That's what this guy is right here. And a good example of that, let me just jump back to where we were when we did down and then across. So as you see, I'm going down, but it's projecting it to the tool plane. So that purple line represents the tool plane. This is a prismatic toolpath. So I can go up and down in Z. I can choose any bits of geometry I want, as long as when they get projected to the tool plane, they look like a pocket. They're actually this planar guy here rather than the yellow. But again, let me just jump all the way back here. and I'm just going to use the constant Z relationship. As soon as I click on that, it goes around and finds all that for me. If I wanted to do that to start, well, that's why I had them automatically selected. So again, in video 1, we talked about global settings. In my global settings, I actually have these pre-selected so that when I come to a part like this and I'm going to do a pocket, I just have to click on it once and it finds the entire chain for me. Now, you'll notice that the chain that I selected, if I just click on show, is for the larger pocket. But I have some tabs down there that if I go all the way down to the very bottom of the pocket, I'm going to wipe out those tabs, maybe even that center island as well. So I want to account for that. So that is what this 3D model gouge protection is all about. Because I had defined my target earlier on, and we saw that in video 3 of how to set up your stock and your target. So since I have a target definition here, it's actually going to make sure that I don't actually gouge that as I go down. So even though the pocket defines the larger pocket, it's going to avoid those side pockets, those side tabs. Let's go to Tool. We talked about tool setup and tool definition in video 2, so I'm just going to go ahead and just quickly click on my tool. I'm just going to grab my 1-inch tool. In the pocketing toolpath, you can affect your feeds and speeds under the Data tab and your coolant options under the Coolant tab. If I go to Levels, similar to what we saw in video 4, we have control over the levels based off of some predefined features like the target. You can see here it's going to the top of the target, so I don't even have to click on the top face. But if I wanted to, I could highlight this and click on the top face to get that associativity. Or I could just rely on top of target. And likewise, for the bottom of the pocket, I can highlight that, and I'll just click on something that represents the bottom of the pocket. So in this case, that right there. So we have a depth of 1 1/8. Now, I'm using a 1-inch tool. I'm going to take this in 1/2-inch cuts. But 1 1/8 depth divided by 1/2 inch is not going to be an equal number. So I'm going to get some final passes that actually are just the remaining 1/8 of an inch. What I could do is I can click on equal step down, and that will equalize the passes. So if that was going to be 3 passes regardless, now I'm getting 1.125 divided by 3 in terms of the depth of cut. So it equalizes the pressure on the tool. Let's go to technology. So under technology, we're going to see similar functions to what we saw with face melt. We basically just choose from our technology what direction we want the tool to take. We have hatch, contour, hatch plus finish, and plunging pattern. Hatch is basically just a zigzag back and forth. You tell it which direction you'd like it to go. So in this case, user defined angle, 0 degrees, is from the x-axis. If you wanted to go on the y-axis, you put it 90 degrees. Simple enough. If you weren't sure what angle to put it at, then you could click on automatic optimal angle. By doing that, you'll see that it doesn't give you any angle to control. That's because it will analyze the part, analyze the toolpath to see what is the longest path that the tool could take. The nice, smoothest, longest path. Cutting direction, you can define it by your geometry. When you get here, you can say, okay, do you want to keep the cutting direction, or do you want to be able to essentially zigzag? Cutting direction as in one way or zigzag, so meaning that it'll lift the tool up, reposition to continue the same direction, or you can keep the tool down using zigzag. This being a hatch pattern, kind of serpentine pattern, as it gets to the edge, you'll see that it does a straight line there. If you want to kind of smooth things out, you can add a fillet. And then that way, instead of doing a jerky 90-degree turn, you can actually tell it to use a particular radius and smooth the transition from one pass to another. Again, if we click on technology, we go to contour, we get that offset style, that racetrack style there. And the second tab gives us the parameters related to this type of technology. In this case, we can start from the outside going in, inside going out. Same corner relations here. We just have a few other ones. Imagining if we do this right turn here, there might be some material in the corner there. So not only do we have the ability to add a fillet to smooth it out, we can actually add a loop to eliminate any material that would get stuck or be left behind there, a cusp or a burr. We can do the same with sharp. It's just a little more jittery. It just goes out, comes back in, and completes the tool path. Contour, we can tell it if we want to keep climb milling or we'll go to conventional cut. Because we're doing that offset style toolpath, we can tell it to either do a simple linear pass between the offsets. We can do a smooth pass. You can see there's a little squiggle there. And then rounded, gives it even more of a smoother transition. Hatch plus finish is the idea that this is a cavity. This is an internal pocket. So if we're doing that zigzag style from hatch, we might be leaving material behind on the walls. So the hatch plus finish has similar parameters as hatch, just has that final perimeter pass on the outside to eliminate any kind of burrs or cusps that are left on the walls. If this is a very deep pocket or hard material, maybe you want to drill it out. So when you click on plunging pattern, it gives you a series of drilled holes along the pocket. That way you can rough out the material with a drill rather than an end mill. But for this pocket, let's go with contour. We'll go from the inside out, and I'll just leave everything else as the default. Back in the main technology tab, we have control over the overlap. So this is basically overlapping with the previous pass. So it's essentially your step over, but we call it overlap in this one. And our offsets. So pocketing toolpath can be used for roughing or finishing. Difference basically is just how much material I'm leaving behind. If I leave it at 0, I'm doing a finishing pass. I'm roughing out the whole part, though, because there's still lots of material. So in this case, I'm going to leave 10 thou behind. What I could do later is I can use the save and copy option, and then just basically tell it to eliminate that last 10 thou with some changes to my levels and such. But basically, pocketing is both roughing and finishing, just depending on what you check in these options here. In the link section, you have control over how you ramp into the part. I'm just going to leave it at none, but you can see there that it has different ways to enter into the part. And again, because it's a cavity, I'm going to start at just the mathematical center of this geometry that I've selected. So there's really no lead in. The lead out is how to exit from the walls. So you have normal, arc, and tangent. If I do save, calculate, you'll see that the 3D gouge protection came into play, and it did not touch those tabs on the sides, and it actually noticed that there was an island in the middle, so it left material for that, but it actually went into the island to do that last through pocket. Okay, so let's do those side pockets now. So I'm just going to open this up. We'll use the same tool. We'll basically use almost everything the same. I'm just going to do a save and copy to retain all that. All I'm going to do is I'm going to change my geometry. So let's go geometry, new. This time we're going to do those tabs. I'm not going to use anything related to the chains. I'm going to use this option here called Smart Face. What this allows me to do is choose the bottom floor of a pocket. And that will automatically choose the open edges, the outside edges, everything related to the face I'm about to select. So I'm just going to go select other, choose that particular face. You can see it got projected to the working plane, and you can see that it recognized that that is now an open edge. So it basically chose everything for me. If I were to do that in the old way, the way that we just saw, basically using chains, let me do that for the other side pocket here. I would have to do it using chains like we did before, and with my constant Z turned on, everything works the same. I just have to hover over here. Let me just save what we've done so far. I'm just going to get rid of this 3D stock. And that way it makes it a little easier to work with this. The 3D stock was there from video 3, where I defined it as my 3D stock model. So you can review how I did that in that video. So let's edit the geometry now. I've already chosen one chain. I want to add some more. So I'm just going to go to Edit. Okay, and I'm going to grab just that one edge. My constant Z is turned on, but you can see that it recognizes all of that as the walls of a pocket. Now, obviously, my 1-inch tool is not going to fit in there. I need to tell it that it actually is open on this edge. I can right-click on this, go to Mark Open Edges, and then individually choose the edges that are open. So that one there, and there. So that is understood to be a pocket, the limits of which you can see there, but it's open on that side, so the 1-inch tool can get in there if it can. But obviously, that is some extra clicks. If we have the ability to just choose faces, that's preferable. So we're just going to do that real quick. You can see that In the time it took me to do that one pocket, I just need to do 3 clicks and I'm already done. It recognizes open edges. By default, it's doing climb milling. Everything is in the direction I need it to go. So I'm just going to click the green check mark to accept that. Because I did a save and copy, I'm leaving all of this the same. I'm still doing the 3D gouge protection. I'm using the same tool and thus the same feeds and speeds. In terms of levels, I'll let it go to the top of the target as well because that's how much material was still left behind by the previous tool path. But my depth will be taken from the chain that I just selected or the face that I just selected. But just in case, I'm going to click on that face again just to make it associative. That color indicates it's associative to that face. If I go back to the original Inventor part and change this pocket's height in any way, this toolpath will always go down to that particular face as the bottom of the pocket. I'll leave the half-inch step down related to the 1-inch tool. But again, equal step down means that it's just going to equalize that. So if this would have been 2 passes, 1 of a half-inch, and then 1 of the 375, this would still be 2 passes, but now it's just going to be the 875 divided by 2. Everything else here is the same. I'll just leave it as contour. Although I'm going to say do the contour from the outside going in, and because we have an open edge to our pocket, we have open pocket options here. I'm just going to say approach from the outside. So regardless of what ramping strategies I put in here, now that it knows it can approach from the outside, now that it knows it has an open edge to do a side entry, it won't even look at the ramping. Do a save and calculate, and you can see that 1-inch tool has now gone in and done those side pockets. Let's do the outside of the part. So you saw me hide my stock. We know that the stock is there. I'm just going to bring it back in because I want to use the edges of that stock. Now you can use the edges of the stock from this 3D model. You could use the sketch that's generated like we saw in video 3 as geometry as well. As long as it's a piece of line or arc geometry, you can use it as your chain selection. So let's do the outside of the part using those edges. We'll go pocket, new geometry, and whenever you do chains in pocketing or profiling or any other geometry inside of SolidCAM, you want to start from the outside in. I want to tell it to machine all the material on the outside, but stop at the outside edge of the target. So I need to go from the outside in. I'll say top edge of the stock, and then top edge of the target. So now I have 2 chains. I'm telling InventorCAM to work in between those 2 chains. But obviously the 1-inch tool doesn't fit in there. So again, I need to set an open edge. So I'll right-click on that first one. This time though, I know the whole thing needs to be open. I'll just click on Mark Chain as Open. So all the edges contained in chain 1 are now open. This is telling Inventor that this is the outside edge of the stock. It can do side entries. It can go over those lines. Basically everything I needed to do the outside of the part. So I'll click on the green check mark there. 3D gouge protection, we'll turn that on just in case. Again, I could have defined a holder in my tool. So maybe I want to gouge check against that as well. Levels, we'll say from the top of the target. And I'm actually going to go down to the bottom of the target. Bottom of the target, it's red from the solid. It's red from my target definition. But bottom of the target, I might actually want to go just a little deeper only because maybe there is not a good edge on my end mill, or maybe there's a corner rat on my end mill that I need to account for. So in the delta box, we can go an incremental amount from whatever I've defined as my pocket depth. In this case, the bottom of the pocket. So from the bottom of the pocket, let's put in negative 30 thou. We'll still do an equal step down of half-inch. So it'll calculate all that for me, what that depth truly is, and how to equalize the steps. We'll still do a contour style. We'll start from the outside. And again, we have an open pocket, so I'll tell it we'll just approach from the outside. Do a save and calculate, and you can see now from this top view that it's doing the outside of the part. Does an entry, goes around, pocket is done. Now, even though it's the outside edge of the part, there's no flat bottom, that is still considered to be a pocket because you're choosing chain geometry and you're basically saying to InventorCAM, machine everything you find inside of this chain. So we used a 1-inch end mill to actually do all this part, but the corner rad on this inside pocket here is actually much smaller than that. So how do we handle that? Well, I could go back and actually start a brand new pocketing toolpath just to do those corner edges, or do a profile like we'll see in video 6. Or I could just take advantage of the fact that we have an updated stock. If I just check this box here and bring this in here, you'll see that it shows us that there is some extra material in those corners. That's because the 1-inch tool cannot do that. So using currently defined things, the updated stock and the target definition, I'm going to take advantage of that, and I'm going to do some rest operations. So let's start with the first toolpath. We just open this up. We can do a save and copy. Geometry, we'll leave the same. Tool, let's go down to a smaller tool that goes in those corners. So let's say we're looking at our 1/4-inch tool. Obviously, this tool can get into the deeper areas. I'm going to do it as the same depth. In this case, depth of cut. Let's put it at something a little more proper for that one. And under technology, everything is the same. We're going to do the same toolpath. The difference being, though, if I were to hit save and calculate now, it would redo the entire pocket. It thinks I'm telling it that particular chain, I want to redo the pocket. I want it to actually understand that this is a rest operation, meaning it will remove the remaining stock. So I'll just go rest. It opens up a rest tab, and I'll tell it the previous tool diameter was 1 inch. Previous wall offset was 10 thou. All I got to do now is do a save and calculate, and it does what was left over by that previous tool. All those corners. Simple enough. And I could do the same for the other toolpath. Again, we'll just do a save and copy, and then we'll go and change the tool. We'll make sure our levels, again, are a little more appropriate. And under this technology, we'll set it to rest, and we'll do the same thing. There was a 1-inch tool, previous wall offset, 10 thou. Save and calculate. And again, that one goes to the corners there because that was what was left behind by the 1-inch. By doing a save and copy, they're actually out of order here. You can see that I'm going back and forth between tool 57 and tool 23. What I could do is I can just left click on the icon and drag it to the end. And I'll do the same with this one here. So basically, the pocketing toolpath does any cavity or any step that you see. You can do the rest operation to step down your tool. You can keep doing rest operations as much as you need to keep stepping down the tool to get tighter and tighter into the geometry. There's an auto gouge checking in there, as you saw, so it can eliminate any kind of gouging with those steps. So you can freely choose your chains or your faces and get them to generate the pocketing toolpath you're looking for. Any questions of this or anything else from InventorCAM, just give us a call at 1-866-975-1115, extension 2. You can send us your parts or your questions via the ticket system at solidcamsupport.com. And stay tuned for the rest of the videos in this introductory series. Thanks for watching.